When you hear the term machine learning, your mind probably jumps to these incredibly complex algorithms, maybe some futuristic AI, right? But what if I told you that's just the shiny part on the surface? That's really just the tip of the iceberg. Today, we're going to pull back the curtain and look at the real nitty-gritty work that actually makes a machine learning project tick. And trust me, you might be surprised by what we find. This quote right here, it just hits the nail on the head. It is so easy to fall into the trap of thinking that machine learning is some kind of magic black box. You just throw a bunch of data at it and poof, out comes the answer. But the reality, it's so much more disciplined. It's a structured and honestly, a surprisingly manual process. So to really wrap our heads around this process, let's try an analogy. Think of it like this. Building a machine learning model is a lot like cooking a gourmet meal. I mean, you can't just throw a bunch of random ingredients into a pot, cross your fingers, and hope for something amazing. No way. You need a plan. You need meticulous prep work, and you absolutely need a solid recipe. And just like any master chef follows a detailed recipe, machine learning professionals follow a standard roadmap. This thing guides them step by step to ensure that the final result is reliable, it's effective, and it's not just some lucky guess. That industry standard recipe actually has a name. It's called CRISP-MLQ. Yeah, I know, it's a bit of a mouthful. It stands for Cross-Industry Standard Process for Machine Learning with Quality Assurance. But all you need to know is that this is the framework, the systematic approach that underpins almost every single serious ML project out there. So this recipe of ours has 6 main phases. First, you got to figure out what dish you're even making. That's understanding the business goal. Then comes all the prep work, the data engineering, which is what we're really going to focus on today. After that, you actually cook the meal. That's model engineering. You check the seasoning with quality assurance. You serve it up through deployment. And finally, you monitor it to make sure everyone's happy. You can't skip a single one. Now, here's the thing. While all 6 of those phases are absolutely critical, one of them, just one, takes up a shockingly huge amount of the total time and effort. It's the part that gets glossed over in the movies, but it's where pretty much all the real work happens. 80%. That's right, let that sink in for a second. Up to 80% of an entire machine learning project is spent on just that second phase, data engineering. In our cooking analogy, this is all the unglamorous prep work, the washing, the peeling, the chopping, the measuring, all before you even think about lighting the stove. And this is exactly why all that prep work is so crucial. You've probably heard the old saying in computer science, garbage in, garbage out. And it's a classic for a reason. It's simple. If you try to cook with rotten vegetables, you are going to get a disgusting meal. It doesn't matter how amazing a chef you are. The exact same thing's true for data. So what does this 80% of the work actually look like? Well, it mainly boils down to these key tasks. First, you have to get in there and really understand your ingredients, your data. Then you've got to clean it up. Next, you have to translate it into a language the machine can actually work with. And finally, you standardize everything so it's all comparable. Okay, so let's get our hands dirty and see how this actually works, starting with cleaning and translating the data. See, real-world data is, well, it's a mess. It's almost never perfect or complete, and we have to fix it before we can even dream of using it. So you open up a dataset, and here's a super common problem you'll see right away, missing values. You'll often see them written as NaN, which just stands for not a number. An algorithm can't do math on an empty space. If we try to feed this data in as is, the whole system will just crash. It breaks. Now, one of the simplest solutions is to just get rid of any rows that have missing information. It's like finding a bruised apple in a barrel. You just toss it out. A single line of code can drop all those rows, and boom, we're left with a smaller, but now totally complete dataset. Okay, we've handled the empty spots. But wait a minute. What about all the data that isn't a number in the first place? Machine learning models, at their core, they're just math. They crunch numbers, not words like red or green or blue. So how in the world do we translate these useful descriptions into a format the algorithm can actually understand? This is where we use a really clever technique called one-hot encoding. What we do is take that single color column and we basically blow it up into multiple new columns, one for each possible color. Then we just use a 1 or a 0 to show, yep, this one's red, or nope, this one's not green. And just like that, we've successfully translated words into numbers, and we haven't lost any of the meaning. Pretty cool, right? All right, our data is clean, there are no more empty spots, and everything's a number. We should be good to go, right? Well, not quite. There is one last crucial prep step. We have to level the playing field to make sure all of our features are on a comparable scale. Just look at this example. We've got age, with numbers in the tens, and salary, in the hundreds of thousands. Now, to a naive algorithm that doesn't know any better, the giant numbers in the salary column are going to look thousands of times more important than age, simply because the numbers are bigger. This can completely throw off our model and give us garbage results. So to fix this, we use a technique called feature scaling. A really common way to do it is called min-max normalization, and all it does is it rescales every single feature so they all fit within the exact same range, usually between 0 and 1. Now, age and salary are on the same scale. They're on a level playing field, and the algorithm can judge them fairly based on their actual importance, not just the size of their numbers. And with that, you can breathe. Our prep work is finally done. We have taken this raw, messy, real-world data, and we have meticulously cleaned it, translated it, and scaled it. Our ingredients are finally prepped, perfectly measured, and ready for the main event. So let's just quickly retrace our steps on this whole data prep journey. We started by just exploring the data to see what we had. Then we had to handle all those missing values. After that, we encoded our text data into numbers. And finally, we scaled everything to make it comparable. That was a lot of work. And this right here, this is the key takeaway. After all of that work, that entire 80% of the project we talked about, only now is our dataset finally ready for a machine learning algorithm. All of that effort was just to get to the starting line of what most people actually think of as machine learning. So, after all that meticulous preparation, our ingredients are perfect, the data is clean, it's balanced, it's ready to go. The only question left is, what happens when we finally turn up the heat and unleash the algorithm? We'll find out.